Dental casting alloys used in prosthodontics. History of alloys. In 1880, William Target, who introduced the lost wax technique. It is a revolution in the history regarding the alloys. 1927, National Bureau of Standards introduced the classification as Type 1, Type 2, Type 3, and Type 4 based upon the soft, medium, hard, and extra hardness of the material. In 1930, base metal removal partial denture alloys were introduced like nickel chromium and cobalt chromium. So the cast is low and better mechanical properties were achieved. 1955 to 1960, a breakthrough in dental technology, a successful veneering of the metal structure with dental porcelain happened. 1970, gold, palladium, silver were introduced, which is the first low gold alloys. Gold, palladium alloys, which were silver-free, were also introduced. 1978, price of gold went so high that attention focused on noble metal alloys to reduce precious metal content, yet to retain advantage of noble metals for dental use. The chromium, cobalt, nickel-based alloys, as covered by ADA number 14, they require minimum 85% weight of chromium, cobalt, and nickel. So, the iron-based corrosion-resistant alloys as well as the iron-chromium casting alloys were excluded. Base metal alloys. According to ADA, the following combinations are available like cobalt, chromium, nickel, chromium, and the beryllium, nickel, cobalt, chromium, and titanium, aluminum, vanadium. Nickel chromium beryllium alloys, which contain nickel, it is to about 82%, chromium to about 20%, beryllium to about 12%. They also have aluminum, carbon, gallium, iron, manganese, molybdenum, silicon, titanium, and vanadium. The advantages are it is low in cost, low density, which permit more casting per ounce, high sag resistance, which can produce thin castings, poor thermal conductor, and it can be easily etched. The disadvantages are it cannot be used in patients with nickel sensitivity. The beryllium exposure, which may be harmful to technicians and patients. The proper melting and casting is a learned skill. And then the bond failure, which is very common in the oxide layer. And high hardness, it may wear the opposing teeth. It is very difficult to solder and difficult to cut through cemented casting. The Occupational Health and Safety Administration (OSHA) specifies that exposure to beryllium dust in air should be limited to a concentration of 2 micrograms per meter. So the nickel chromium beryllium free alloys. It contains nickel of till 77%, chromium till 22%. Other than that, boron, iron, molybdenum, niobium, and tantalum. So the advantages are they don't have any beryllium, so it is cheaper and low density. Disadvantages, they cannot be used in patients who are sensitive to nickel. They cannot be etched properly. They may not cast as like nickel chromium beryllium alloy. They produce more oxide than nickel chromium beryllium alloy. The cobalt chromium alloy. So it is available in two different types. Type 1, which is having a fusion temperature greater than 2400 Fahrenheit. And type 2, the fusion temperature is less than 2400 Fahrenheit. The composition is cobalt, which is a maximum of 68%, chromium to about 34%, and the trace element which include molybdenum and ruthenium. Disadvantages are more difficult to process than nickel-based alloys. They are having high hardness, so obviously they can wear the opposing teeth. They can oxidize more than both nickel-based alloys, and no information on long-term clinical studies. General features of removable partial denture alloys. Base metal alloys have been used for the fabrication of cast removable partial denture since 1930. So this combination of low cost and superior mechanical properties lead to this wider spread application even before the price of gold was deregulated. One disadvantage of this type of alloy is the complexity in the fabrication of dental appliance. A high fusing temperatures precludes the use of usual gas air flame for casting. The extreme hardness of this kind of alloy requires the use of special equipment for cleaning and finishing the work after casting. So to conclude, these combinations of alloy, which is widely used in the prosthetic, though the usage of noble metal alloys are reduced, still it has its own benefits and disadvantages. So nowadays, very commonly, the nickel chromium, cobalt chromium alloys are commonly used in the day-to-day life of the prosthetics replacements. Thank you.